Hey guys, today we're going to learn how to solve a right triangle. But first, a couple objectives. For one, students will be able to use sine, cosine, and tangent efficiently in a right triangle. Two, students will be able to effectively be able to solve a right triangle. So, let's start off with the sine, cosine, and tangent. The sine is equal to the opposite over hypotenuse. That's referring to the angle, the sides of the triangle, like relative to the angle that we're using, but we'll get to that in a second. Cosine is the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. So, let's try to use these in a right triangle. First off, if we have a right triangle with a 3, 4, and 5, and a right angle here, we can try to solve this angle. We'll call it x. Now, if we want to use sine to solve this, the sine is the opposite over the hypotenuse. So we go to this angle and the opposite side over the hypotenuse. So this will be sine of x equals opposite over hypotenuse, 4 over 5. Now, to get the answer, we have to get x by itself. So we have to put sine inverse on both sides to get rid of the sine. So it all comes out to x equaling the sine inverse of 4 over 5. You can write sine inverse as sine to the negative 1, or you can write it as arc sine. Either way works. Now, when you plug this into your calculator, you just use the second button and the sine button. So, when you plug that in, it all comes out to x equals 53.1. So we can plug this into our triangle as 53.1 degrees. Now, if we want to try and solve this angle, we can use cosine. We'll call this angle y. So, we'll set it up the same way. Cosine of y is equal to the adjacent of the hypotenuse. So, go to this angle, the adjacent over the hypotenuse. Adjacent, that's the opposite. Adjacent over hypotenuse. So it will be 4 over 5. Now, to get y by itself, we just do the cosine inverse. It's cosine inverse on both sides. And again, that's just the second button and the cosine button. So this comes out to y is equaling the cosine inverse of 4 over 5. And when you plug that into your calculators, you will get 36.9. We can plug this into our triangle as y as 36.9 degrees. Now, we've used sine and cosine. Let's try tangent. We'll use this angle again, but we'll call it z this time. So, we'll set it the same way. Tan of z is equal to the opposite over adjacent. So opposite side over adjacent side, 3 over 4. Now, we do the tangent inverse on both sides. So we get z is equal to the tangent inverse of 3 over 4. And when you plug that into your calculators, you get 36.9 degrees, which is the same as our cosine, which is good because they're the same angle. Now, to check this right triangle, we need to make sure that all these are correct by making sure they add up to 180. So, we have 53.1, 36.9, and 90. 4 plus 6 is 0. 6 plus 3 is 9, plus 9 is 18. 180, we are good. Alright, so Now for a real life example. If we have a loading dock that is 20 foot high and the parking lot is 100 foot long, and we have a camera right here that we need to reach to the end of the driveway, then we need to know the angle of this right here. So, first off, we need to find this x. We can do that by doing the Pythagorean theorem. 20 squared plus 100 squared is equal to x squared. This is 400 plus 10,000 is equaling x squared. So therefore, 10,400 equals x squared. Square root both sides. And this all equals out to 101.9, but we'll use 102. Alright, we can plug in 102 for x here. Now, we know that this is a right angle. So now we just need to find these two angles. Y and Z. We can use sine, cosine, or tangent. I'm just going to use sine. So, it's opposite over hypotenuse. So, opposite over hypotenuse. So, sine of y is equal to 100 over 102. Now, we skipping this step, we'll get y equals the sine inverse of 100 over 102. And when we do that, we get 78.7 when you plug that into your calculator. So, we can plug this into our triangle as 78.7 degrees. Now we just need to find this one. We'll use, let's do cosine. Cosine of z is equal to, actually, let's use tangent. That way, it reduces. Tangent of z is equal to 20 over 100 or 1/5. Now, we can sine or tangent inverse both sides, getting z is equal to the tangent inverse of 1/5. And when you plug that into your calculator, you should get 11.3. Now, we can plug that into our triangle as 11.3 degrees. And all we need to do now is check our angles. 78.7, 11.3, and 90. 9, 10. 8, 9 plus 9 is 18, 180, and we are good. Thanks for watching. Hope you guys learned something.